Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 28, 2025, about 4 days ago. The standout idea is a single 3 billion parameter model that learns interleaved vision, text, and action, delivering state-of-the-art embodied reasoning and robot control with results like RoboV QA-Blue4 equals 58.5 versus GPT-4o at 47.2. The paper is titled EmbodiedOneVision, Interleaved Vision Text Action Pretraining for General Robot Control, and as we'll see later, the implications for model training are quite significant. Beyond vision language, it unifies images, video, robot state, and continuous actions using autoregressive decoding, plus flow matching, denoising, and demonstrates strong generalization across long-horizon, dexterous tasks. Also, the authors shared an actively developing GitHub repo. You'll find a clear README with install steps, Hugging Face-based inference code, dataset config examples for interleaved multimodal and robot control data, fine-tuning commands, benchmark tables, and a roadmap. The repo includes assets, configs, and pointers to EO data 1.5M and EO bench. On Hugging Face, EO1 3 billion parameters is ready to download, with transformers and robot examples showing multimodal inputs and generating text plus continuous robot actions. Quick Python snippet included. Alright, Figure 1 explains how a single backbone handles reasoning and control because all modalities flow through one interleaved token stream. The shared transformer takes vision tokens, text tokens, robot state, and noisy action tokens, then decodes with two heads, a language head for text, and a flow head for continuous actions. The top panels illustrate tasks, while the middle bar shows the unified model and heads, and the bottom row depicts the interleaved tokens. Figure 2 shows how the model keeps causality intact when actions and language are interleaved. The strategy samples short subsequences around each action block, and, for middle action blocks, swaps noisy action tokens with clean ones so later tokens can attend to the right context. Noisy action means an action vector perturbed with random noise for denoising training. This lets one backbone learn mixed modality generation efficiently without extra action modules. So Table 1 spells out the training fuel behind EO1, which matters because the model's breadth comes directly from data diversity. The table lists 3 sources: web multimodal pairs, robot control episodes, and interleaved embodied data that mixes images, language, state, and actions in temporal order. Interleaved embodied data means sequences where perception and text appear, alongside continuous actions, so the model practices reasoning while acting. The counts show web data at 5.7 million items, robot episodes at 1.2 million, and interleaved examples at 1.5 million. So Table 3 summarizes head-to-head robot control, showing that EO1 leads across all Libero subsets with the highest overall success rate. Libero tests 4 skills, covering spatial changes, new objects, goal semantics, and long-horizon plans, which together probe generalization. The highlighted bottom row reports near-perfect scores, so the model ranks first consistently. The comparison includes diffusion and transformer-based baselines, indicating gains are broad rather than task-specific. So Table 2 shows that the unified model leads embodied reasoning across diverse tests, which means it answers grounded questions and plans over time better than comparable systems. RoboV uses Blue4 to score long-horizon visuospatial answers. EO-Bench Spatial measures multi-view grounding, while EO-Bench Temporal targets sequence reasoning over actions. The bottom row reports the highest scores consistently, so the combined vision, text, and action pre-training pays off. So Table 4 reports simulated control under visual distribution shift, which means the scenes change in color, texture, lighting, or camera pose to test robustness. The table shows 3 blocks for Widow X, Google matching, and Google aggregation, and the highlighted bottom row takes the top average in each block. The strongest gains appear on matching with 76.5%, which signals reliable perception to action grounding. These results matter because lightweight fine-tuning produced broad wins across tasks like drawers and stacking. Alright, 2 takeaways stand out. A single backbone that interleaves vision, text, state, and continuous actions delivers both strong embodied reasoning and reliable control, and the hybrid training with autoregressive decoding plus flow matching denoising is the difference maker. Broader impact, simpler stacks, better generalization, and faster robot deployment. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.